Hi, everyone. Welcome to section 2.2, differentiating with products and quotients. So at the end of today's lesson, we would be able to use a product rule to differentiate functions and use a quotient rule to differentiate functions. So in this section, we're going to be learning two new tools to differentiate functions. So uh, let's look at this quick warm up here. So let's look at this, the way I want to rewrite this as is y equals x squared x cubed, right? So it wants me to find y prime, right? So say I want to find the derivative of that. So what I would then do is maybe combine this, add the exponents, when you multiply, you would add the exponents. So it would be 2 plus 3, which is x to the fifth, right? So in order to find the derivative of this, I would just use a power rule. So this would become, you drop down that 5, you subtract 1. So the derivative of this would be 5x to the fourth, right? Not too bad. Okay, so this is a situation where we have two things being multiplied together, two different functions being multiplied. And we're lucky enough that we can combine it without any problems, right? When we want to find the derivative. But what if that's not the case? What if it's not something really easy to simplify and we want to find a derivative of it? Here's where something like the product rule is going to come into play. And this is a new tool that we'll be using to differentiate functions to make life a lot easier for us. So consider f and g be both differentiable functions, right? Differentiable functions. So what this is saying is that if I want to take a derivative of f and g, these two differentiable functions, there's a formula for that, which would be f of x times a derivative of g of x, meaning like g prime of x, plus g times f prime of x. But we don't really write the notation like that. What we would really write it as is this. Basically, f times g prime plus g times f prime. So that's a product rule. And that's our formula to take a derivative of two functions multiplying each other. Okay, so maybe I'll make that note. For derivative of two functions multiplying together or multiplying each other. Okay, so example one, let's try this out. So differentiate the following. We have f of x equals x squared times 7 minus 3x. So I could distribute this guy in, right? This x squared, I could distribute that in, or I can use a product rule instead of having to do that algebra in the beginning. So I know I need to use a product rule, right? So product rule is f times g prime plus g times f prime. So what I need to do is look at this function here and pick out what my f and g are. So f is typically going to be your first term, your first function, and g is going to be your other function, right? So what I need to do now is find their respective derivatives. So let me go off here, and what I'll have is f is x squared, right? That's just this right here. And I need to find the derivative of that. So the derivative of that, just using power rule, right? You drop down to 2, subtract 1, it's just going to be 2x. Okay. Now, to fill out the rest of this formula, I also need g prime. So I know g right here is 7 minus 3x, right? So 7 minus 3x. And so the derivative of 7 minus 3x, right? The 7 is a constant, so it goes away. And then this x drops. So what I'm left with is just -3. Okay. So putting that all together, right? What this becomes, right? I'm just going to plug it into this formula here such that f prime of x is going to equal f, I guess I'll write it out, f times g prime plus g times f prime, I'll use a different color. F times G prime plus G times F prime. And I'm just going to put in all of these parts. So what I'll have here is F, which is X squared times G, which is G prime, excuse me, -3 plus G, which is 7 minus 3x times F prime, which is 2x. And you can simplify this a bit more, right? -3 times -x squared is -3x squared. And then if I distribute in this 2x, I get plus 14x minus 6x squared. And then if I simplify this out a bit more, right, I have -3x squared and -6x squared. I get -9x squared plus 14x. And that's my answer. Okay, so that is the product rule. All right, so since we're talking about two functions being multiplied, now what if we have two functions being divided, right? And we want to find the derivative. So that comes in with the quotient rule. So the quotient rule is if these two functions are differentiable, right? And we want to take a derivative of them when they are being divided by each other. All right, here's a formula here. Do not be too scared of it. What it's really saying is G times F prime of X minus F of X times G prime of X all over G squared. Okay, so that is the quotient rule. So likewise, it's for the derivative, right? Let me kind of copy this right here. For a derivative of two functions dividing each other. Okay, we want to find the derivative of two functions dividing each other. Little typo there. Okay, so let's go ahead and figure that out. So let's check an example, example 2. Find the derivative of the following. H of x equals 4x cubed minus 7x over 5x squared plus 2. So same thing as with the product rule, we want to pick out an f and g, and typically you always do f as a top and g as a bottom. So you want to use the quotient rule, right? Quotient rule is g times f prime minus f times g prime all over g squared. So we got to find our g prime and f prime and g prime and then put it into a formula and figure out what that is. So my f is just 4x cubed minus 7x, and my f prime, I just got to take a derivative of this. This would just be 12x squared minus 7. Okay, and then my g is 5x squared plus 2. Oops, let me rewrite that. I gotta take a derivative of this. This would be 10x. All right, so now we just gotta put all this into our quotient rule derivative formula. So this means h prime of x, right, is g, which is 5x squared plus 2. Oops. 5x squared plus 2 times f prime, which is 12x squared minus 7. That's this guy right here. Minus f, and here's f, 4x cubed minus 7x times g prime, which is 10x right here, all over g squared. So g squared, which would be 5x squared plus 2 squared. And that's our derivative, right? So if you notice, we can't simplify a lot more. We can expand this out, we can expand this out and expand this out. But for the sake of this class, we will just leave it like that. And that's a correct answer. All right. Correct answer. Setup is good. Okay. So setup is good. And that's all you got to do for this one. And that's, you can leave it like that. So, okay. In the next video, we'll go over some practice problems, but for now, we'll see you next time. Thank you.